Hello students. After the discussion on atomic orbitals, let us discuss how they are represented. Let us take one case, NSX. Here, what is the N term, what is the S term, and what is the X term? Here, N is the principal quantum number, S is a subshell, and X is the number of electrons. That means it can be indicated by the principal quantum number and its respective orbital along with the number of electrons present in it. So it shows that in the N principal quantum number, the subshell is S and which consists of X number of electrons. Let us take one particular case. If the notation is given as 2s1, it indicates that there is one electron in the subshell of a second principal shell. It indicates that there is a single electron in the S subshell of second shell. Second shell means it is a second principal shell, or we can say second orbit. So in this way this type of notation will understanding the number of electron, the principal quantum number and the subshell. Let us take one more example. So what the 3 indicates here, that is the principal quantum number is 3, that means it is the third shell, or we can say orbit or the energy level. Here 1 indicates the number of electron here. P is the subshell. Here if it is written as Px, that means it represents the orbital. P represent the subshell, Px represent orbital, Py is an orbital, Pz is an orbital. So it shows that particularly in the Px orbital there is one single electron. So this notation, that is 3px1, indicates that there is one electron in the px orbital of third principal shell. Therefore, it is written as 3px1. 3px1, let us make in the form of boxes. Here, a box for an orbital, that is square or we can say circular, with an arrow, that is for an electron. It represents the number of electron present in that orbital. So here each box represent an orbital. So 3p, because p have 3 orientations, so we have made 3 boxes. So one of the box represent the px, second box represent py, third box represent pz. So here the arrow mark which have shown here, that is actually representing the electron. A single arrow shows a single electron. 2 arrows shows 2 electrons. So here when you look at the notation, in this only one electron is present. So we have to make one single arrow. And maximum in one orbital, maximum 2 electron can be accommodated. So that means here there is already one electron. So one more electron can be accommodated here. So maximum only 2 electron can be accommodated in a single orbital. Let us take one more case. Here the notation is given 2s2, where 2 is the principal quantum number, s is the subshell, and 2 is the number of electron. So here 2 electrons are there, therefore we have made 2 arrows here. Why we have made single box here? Because it is an s orbital. So s orbital means which have only one orientation, therefore single box. And the 2 arrows which is shown here, that is the electrons. And I told you maximum 2 electrons can be accommodated in a single orbital. Single orbital means single box. So here maximum 2 electrons, which you can find here, it is represent the form of arrows. One of the arrow here, it is in the upward direction and the other arrow is in the downward direction. You can see this arrow is in the upward direction and this one is in the downward direction. It shows that electron which is shown by upward direction, that is a electron in a clockwise spin, and the arrows which is represented downwards, that shows electrons in anti-clockwise spin. As we have learned that electrons have two type of spin, either clockwise or anti-clockwise. So in a single orbital, maximum 2 electron can be accommodated, and one of the electron will have the clockwise spin, the other electron will have anti-clockwise spin. Now let us take the next case, 3d2. 3d2, where 3 is the principal quantum number, that means third shell, d orbital, d is a subshell, and in which there are orbitals, that is 1, 2, 3, 4, 5 orbitals are there. D is the subshell and its orbitals are dxy, dyz, dzx, dx square y square, dz square. So there are 5 orbitals in d subshell. Here the number of electron which is shown here, that is 2. You can see on the power of d there is 2 number. So 2 number means there are 2 electrons. And 2 electrons, you can see they are in the different orbitals. So both have a upward direction. So arrows are in upward direction. So it shows that both the electrons are in the clockwise spin. So when we discussing about the laws related to this one, you'll be clear that why I made the 2 arrows in the separate orbital and why I made both in a clockwise spin. Now each shell have orbitals. The first shell, which is represented by K, where the principal quantum number n is equal to 1. So in the first shell, only one orbital is present, that is 1s. So the representation you can see 1, that is the principal quantum number, and s is the orbital. In the second shell, that is L shell, we can see the quantum number is 2 here. So there are 2 orbitals, we can say 2 subshells are there in this, that is 2s, 2p. 2s, 2 represent for principal quantum number and s is the subshell. 2p, 2 is the principal quantum number and p is the subshell. So here 2s. So what will be the total number of orbitals in this? 2s have single and 2p have 3 orbitals, that is 2px, 2py, 2pz. So total number of orbitals in second shell is, that is 1 plus 3 is equal to 4. Third shell which is represented by M, where the principal quantum number is equal to 3. There are 3 possible subshells are there, that are 3s, 3p, 3d. In the fourth shell, that is n equal to 4, there are 4 subshell, that is s, that is 4s, 4p, 4d, 4f. So when you look at the series here, in the first case only one s is there, one s. In the second case s and p is there. In the third case s, p, d. In the fourth s, p, d, f. So when the principal quantum number increases one by one, extra subshell get added here. So this is about the each orbital having the following subshell. So in this video we discussed about the representation of orbital, that is the notation. In the notation, it indicates that the number of electrons in a particular orbital in a particular principal shell. In this video, we also discussed that the arrow marks are representing the electrons. If the arrow is in the upward direction, that means electron is in clockwise spin. And if the arrow is in the downward direction, it means that electron is in anti-clockwise spin. In this video, we also discussed that K shell, that is the first shell having single orbital, that is S. In the second, there is two orbitals, that is S and the orbitals of P. In the third, S, P, D. In the fourth, S, P, D, F, and the further will be so on. So this is all about in this video we have discussed. Thank you everyone.